Okay, so we are doing a distance problem, and our problem is my friend goes to UW Eau Claire and I go to UW La Crosse, which are 90 miles apart. One weekend we decide to meet to hang out. I leave campus when I get done with class at 2 o'clock. My friend leaves her campus at the same time. After 45 minutes, we meet. Find my friend's average rate of travel if I travel 15 miles per hour faster than her. So, a few things to remember when we're doing distance problem. Distance equals rate times time. And in case you forgot, rate is the speed at which you travel, which is usually labeled in miles per hour or kilometers per hour, but in this case it's going to be miles per hour. So the first thing we're going to do is go back in our problem and pick out the important information that we need to know. So my friend goes to UW Eau Claire and I go to UW La Crosse, which are 90 miles apart. One weekend we decide to meet to hang out. I leave campus when I get done with class at 2 o'clock. My friend leaves her campus at the same time. After 45 minutes, we meet. Find my friend's average rate of travel if I travel 15 miles per hour faster than her. So then, with this information, we're going to fill in this chart. And so this is going to be me, and this is going to be my friend. And then distance equals rate times time. And we're going to define our variables where x is going to be my friend, and y is going to be me, or my rate and my friend's rate. So my rate is y, and my friend's rate is x. Our time, both of our times is 45 minutes, so in decimal form that's going to be 0.75. We both have the same time. And then we don't know each of the distance each of us traveled, but we know combined it was 90. So I'm going to put that in the middle as combined distance. So then we're going to take this chart and use it to make our equations. So we have our chart all filled in, and the next step is going to be to write two separate equations. So our first equation is going to be my friend's rate equals my rate minus 15 because I travel 15 miles per hour faster than her. And then our second equation is going to be our combined distance, which is 90, equals both of our rates times both of our times, and because our time is the same, we can put that out front. So we have 0.75 times both of our rates added together. And if you don't understand that, I can explain it a little better. So this is our combined distance. So my distance plus her distance, but we don't know the individual distances. And then we both traveled the same time. And these are our rates added together. So we could have wrote it 0.75x plus 0.75y. Because this is our two distances added together. So it's going to equal our two rate times time added together. So we just simplified that, or factored that to that. Okay, so then we need to solve our first equation, which is already solved for us, so we don't really have to do anything. So then we're going to plug this whole thing into this equation. So then we have 90 equals 0.75 y plus 15, minus 15, y minus 15 plus y. So then we're going to solve this problem by distributing 0.75y, so we have 0.75y minus 14.25 plus 0.7y. And then we're going to add 14.25 onto this side, so we have 104.25 equals, and we're going to add our 0.75y plus 0.75y equals 5y. And then we're going to divide 104.25 by 1.5, and we're going to get y equals 69.5. And then we're going to take this and put it back into that problem. So we have x equals 69.5 minus 15. And do the math, and that equals 54.5. So then we're going to go back, and our variables were x is my friend's rate and y is my rate, and the question was find my friend's rate, so we're just going to take x and we're going to say the answer is 54.5 miles per hour. And that's the answer to our distance problem.